A swing in baseball may seem simple, but in less than a second, it becomes a battle of probabilities, decisions, and hidden mathematics. So if mathematics is what truly controls the game, then the real question is, are we really seeing the game in its full complexity or just its surface, while the real game happens beneath it?
Hello everyone, my name is Martin Valcárcel. Today we are going to dive into the intersection of baseball and mathematics. I will guide you step by step through how mathematics is used to measure and evaluate professional player performance in baseball. The objective of this presentation is to demonstrate how averages simplify complex data and real-life decision making. By the end, you will understand how a single metric can tell the story of a player's entire season. At its core, an average is calculated by adding all values and dividing by the total number of observations. But beyond the formula, an average represents something deeper. It summarizes many different results into one single value. In real life, data is not uniform. Some results are high, some are low, and others fall in between. Instead of analyzing every single value, we use one number to represent them all. That number is the average. You can think of it as a balance point, a value that represents where the data is centered. Now imagine this, if a player hits the same number of home runs every season, the average stays exactly in the middle. Nothing changes. It's like balancing a broom on your hand. When the weight is evenly distributed, it stays stable. But what happens if one season suddenly has much higher performance? Now the balance shifts. The average moves toward that higher value. Why? Because the weight of the data has changed. This leads to a key idea. The average is not fixed, it adapts depending on the data. If more values are high, the average increases. If more values are low, the average decreases. So instead of being a static number, the average reflects where the data is concentrated. In baseball, performance is never constant. Players have good games, bad games, and everything in between. But when we calculate the average, we find a single value that represents their overall performance. So instead of chaos, we get clarity.
Now, let's apply this idea with a real example. We calculate the average using this formula. Average is equal to sum of all values divided by number of values. First, we write all the data in the numerator. 11 plus 16 plus 24 plus 19 plus 27 plus 23. Then we write the number of seasons in the denominator, 6. Then we add up all the data in the numerator, which gives us 120, and we divide that result by the number of seasons, 6, which gives us 20. This means the player averages 20 home runs per season. If we visualize this on a graph, we can draw a line at 20. Some seasons are above it and some are below. If we redistribute the differences, the data balances perfectly around that point. That is why the average is called a measure of central tendency. It shows where the data naturally centers.
So an average is not just a calculation, it is a balance point that reveals patterns hidden within the data. And in baseball, those patterns can define how players are evaluated and understood. Before we analyze each metric, we need to understand something important. In baseball, performance is not measured with a single number, but through different metrics that capture different aspects of the game. However, all of these metrics are connected by one idea. They use mathematics to transform complex performance into simple values. Some use division to create averages, others use multiplication to assign value, and others use addition to combine information. So as we go through each metric, pay attention not only to what it measures, but to how mathematics is used to build it.
Let's look at the most famous metric, batting average, commonly known as BA. This is the purest form of an average. It uses division to compress many atoms into a single number that represents consistency. Its formula is H divided by AB. Here, division compares success to total atoms. H means hits. A hit is when you hit the ball and safely reach a base without a defensive error. AB means at-bats. It's a turn where you actually try to hit the ball, and it counts when you get a hit, make an out, or a strikeout. But it does not count if you get a walk, are hit by a pitch, or hit a sacrifice fly. Example 1. Ty Cobb once hit 420 in a season. He had 248 hits in 591 at-bats. Example 2. A struggling player hits 179. He has only 10 hits in 56 at-bats. Moving forward, we have the on-base percentage, or OBP, which rewards patience. This average expands the idea of success. It still uses division, but includes more ways to reach base. Its formula is H plus BB plus HBP divided by AB plus BB plus HBP plus SF. Here, we use addition to combine different types of success, then division to compare them to total opportunities. BB means based on balls, occurs when the pitcher throws 4 balls outside the strike zone and the batter does not swing. The batter is awarded first base. HBP means hit by pitch, occurs when the pitcher hits the batter with the ball and the batter does not swing. The batter is awarded first base. SF means sacrifice flies, occurs when the batter hits a fly ball that is caught and a runner scores after the catch. Example 1. Ted Williams got a 482 OBP. In this season, he had 145 hits, 145 walks, 2 hit by pitch, and 0 sacrifice flies in 459 at-bats. Example 2. A player with 40 hits but 0 walks, 0 sacrifice flies, and 0 hit by pitch in 200 at-bats, his OBP is only 200. But hits aren't everything. We also measure power with a slugging percentage, or SLG. This is a weighted average. It introduces multiplication to give more value to stronger hits. Its formula is TV divided by AB. Then we use division to average that value. TV means total bases. It is the sum of singles which take you to first base and are worth 1, doubles which take you to second base and are worth 2, triples which take you to third base and are worth 3, and home runs which allow you to run around all the bases and score and are worth 4. Example 1. Max Muncy once got a 582 SLG in 2018. He connected 50 singles, 17 doubles, 2 triples, and 35 home runs in only 395 at-bats. Example 2. A hitter has 50 hits, but all are singles. In 200 at-bats, his SLG is only 250. If we combine them, we get the ultimate tool, on base plus slugging, or OPS. OPS combines 2 averages into one. It uses addition to merge consistency and power. Its formula is OBP plus SLG. OBP means on base percentage. SLG means slugging percentage. This shows how multiple mathematical results can be combined into a single metric. Example 1. Shohei Ohtani had a historic 2025 season with a 1.014 OPS by adding his 392 OBP and his 622 SLG. Example 2. A player with a 239 OBP and a 301 SLG has an OPS of 540, far below the league average. Now let's shift to the mound with the earned run average, or ERA. This average flips the perspective. Instead of measuring success, it measures damage prevention over time. Its formula is ER times 9 divided by IP. Here we use multiplication to scale performance to a standard 9-inning game and division to average it over innings pitched. ER means earned runs, runs that are the pitcher's responsibility. IP means innings pitched, the number of innings the pitcher has thrown. Example 1. Yoshinobu Yamamoto had a 2.49 ERA in 2025. He allowed 48 earned runs in 173.2 innings. Example 2. A pitcher allows 60 earned runs in 90 innings. His ERA is a very high 6.00.
These averages are the language of modern baseball. They do not just describe the game, they explain it. They allow teams to evaluate players, make strategic decisions, and even predict future performance. Without averages, baseball is chaos, but with them, it becomes a strategy. To conclude, averages bridge the gap between complex performance and simple understanding. Mathematics is not just about numbers, it is the universal language of performance. I hope this presentation has given you a clearer perspective on how data defines the game of baseball. Thank you for listening, and I hope you enjoyed this journey through sports and mathematics.